example 9 asks us to solve the following equations. Equation A has 2 to the x minus 3 equaling to 16. Okay, so since we have our exponent with a variable now, there's lots of things to consider. This is a little more difficult. One thing that we can do, because there are very few terms, just one term on each side, is we can try to make them look alike. Well, one thing that I do know that 16 actually is 2 to the 4th power. So if you know that like 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, I can replace these two things. They are equivalent, and since they're equivalent, I can just replace it. So I'm just going to go ahead and say, okay, well, this is the same thing as 2 to the 4th. Well, now that I have that statement written, if I have 2 to a power equaling 2 to a power, I can remove the bases of 2. I can easily say here that, hey, x minus 3 equals 4. And therefore, I would add 3 to both sides to make x equal to 7. Now, the problem can become more complicated, certainly if we have some different things. So let's say we have 9 to the 5x plus 1, and that equals 3 to the x over the 4th root of 27. So lots of different things going on here. Not only do I have 3 different numbers, but I've got a fraction on one side. I even have a root in there. So how do we interpret that? So just like we did in part A, we're going to want to make things look the same. Now, once we get everything into a common base, so like over here we have a common base of 2. That's what we wanted to do. Once we have a common base, then we can start stacking things and start using our rules for exponents. But we can't do it until we get to that. So I'm going to recognize here that I have a 9, a 3, and a 27. Those are my important numbers. Those are all different powers of 3. Right? We have 3 to the 1st is 3. 3 squared is 9, and 3 cubed is 27. So I'm going to replace these things. Just right off the bat, that's what I'm going to do. Okay, so I'm going to have 3 squared to the 5x plus 1, and that's going to equal 3 to the x over the 4th root of 3 cubed. So at this point, now I can kind of apply some rules and some things that I can do. Let me convert to a different color here. Well, if I take a power to a new power, right, that's like stacking. So I'm going to multiply those exponents together. I'm going to end up with 2 times 5x plus 1. So I'm going to have 3 to the 10x plus 2 now. Now, if you wanted to, hold a step and just say 3 to the 2 times 5x plus 1, that's also fine. Now, that's going to equal 3 to the x over, now, here's a big one. So a 4th root is kind of undoing something to the 4th power. And when we undo things, right, this is going to be it's going to work like multiplication. So 3 to the 1/4 represents the 4th root. But we're actually doing 3 to the 3 cubed to the 1/4. So this actually makes 3 to the 3/4. Okay, I'm sorry if that's hard to read that. Let me rewrite this real quick. 3 to the x over 3 to the 3/4. Now, the 3 on top represents the power. So we're taking 3 to the 3rd to the 1/4 power. So 3 times 1/4 makes 3/4. Okay, so that's where we are at this point in time. Now, we have this, so we have 3 to the 10x plus 2 equals 3 to the x over 3 to the 3/4. Well, on this side, we have the same base. And so we can actually use one of our rules of exponents, which says that we can actually combine them together by subtracting one from the other. So what I'm going to do is I'm going to move this term up to the top. So I'm going to subtract away the 3/4 from the top. So I'm going to have 3 to the 10x plus 2 equal to 3 to the x minus 3/4. The bottom, since we took it all away, was 3 to the 0. We took all its exponents away, which is just 1, so we can actually kind of not consider it right now. Now we can say, okay, well now I know that 10x plus 2 equals x minus 3/4. And I can simplify and solve. So I can move my x over to the other side. I'm going to have 9x. Okay, so I subtract an x from both sides. And I'm going to subtract 2 from both sides. So negative 3/4 minus 2 is going to be negative 11/4. And then if I divide this by 9, I'm going to get x equals negative 11/36. And so that you may say, that's a really weird number. Well, that's the only solution to this problem. You want to make sure with this that if it's this type where we have very few terms, that you are firstly converting everything to the same base, and then you just need to apply the rules of exponents until you get something similar on both sides. You can set them equal to each other and solve. So there are many layers to the problem, but they're all little tiny steps, and just making sure that the rule that you pick is the correct rule to apply to the problem.